Thank you for joining us for Plexon video tutorials. Today we are going to go over the appropriate method for measuring power outputs with your PlexBright Optogenetic research system. Here's an example of what a fully functional setup would look like. The Optogenetic controller is used to deliver power through a commutator to two LEDs affixed to the bottom of the commutator. The LEDs are allowed to freely spin around as the mouse down below freely moves throughout the chamber. Patch cables transmit the light from the LEDs to those fiber stub implants on top of the mouse's head, which deliver light directly into the brain. The patch cables are connected to the fiber stubs with ceramic mating sleeves. Your PlexBright system consists of at least one of two LED drivers to control power outputs, and at least one of three LED modules, either the tabletop, compact, or head-mounted variety. For the compact and tabletop LED modules, a patch cable is needed to transmit the light from the LED to the tissue. These patch cables come in one of two varieties, either bare fiber tips, for transmitting light directly into the tissue with head fixed or slice preparations, or, with freely moving animals, a detached patch cable with a ferrule tip is connected to a fiber stub implant, which delivers the light directly into the brain. Light output can be affected by issues at any of the connection points within this system, ranging from power delivery issues at the level of the driver, to broken fibers within the patch cable, to occluded ferrule tip to fiber stub implant connections. Here we will show you how to appropriately measure power outputs to assist with diagnosing any power issues you may have with your PlexBright Optogenetic system. Before we begin, it's important to know what your expected light output should be at each of the connection points. Light outputs can be measured at the LED module itself, the ferrule or bare fiber tip of the patch cable, or the tipper of the fiber stub implant if used. Plexon offers two different fibers for patch cables: high performance fiber with a larger numerical aperture for capturing more of the light produced by the LED, or a high durability patch cable that can withstand substantial twisting and bending, but with a smaller numerical aperture and somewhat reduced power outputs. The head-mounted LEDs are directly connected to the fiber stub implants on the animal's head. Thus, no patch cable is required. Notice the higher power outputs at the tissue level because there are fewer connection points between the LED itself and the fiber stub implant delivering light into the brain. A list of these expected power outputs can be found under the Technical Specs tab on our PlexBright Optogenetic Stimulation System webpage. To measure power outputs, you will need a photodetector device. Plexon sells a light measurement kit complete with photodetector adapters that are specially modified for your system components. These ensure accurate power output readouts. The reason we provide these adapters is because of the issue of clipping. LEDs produce a broader cone of light compared to lasers, but some photodetectors are designed with the lasers in mind. Thus, clipping may be observed with some of these commercially available photodetectors. That will artificially deflate the output values observed. The Plexon-specific adapters prevent this clipping issue. Another source of measurement error could be dust and litter from the environment. We provide an optic fiber cleaning kit to assist with cleaning such debris from your connection points to maximize power outputs. Now we will move on to the live demonstration portion of our tutorial. The first step is to note the maximum current level of your LED. Set the LED driver to the maximum current output level for your module. Pick up the integrating style sphere, but notice this detector does not have the special adapter. For this tabletop module, we will need to attach the FC connector adapter to the top of the photodetector. Screw the adapter in tight to secure the photodetector. Note the wavelength on your module. For this blue module, the wavelength is 465. Note the current wavelength setting on your light meter. If it doesn't match, you need to select the appropriate wavelength. Now you are ready to measure power output. 43.3 milliwatts. This is about the power output you would expect from our blue tabletop module. Now we are ready to measure the output from the tip of a compact module, which requires the LC connector adapter. Notice we have switched to a green compact module. The current output is still 300 milliamps. Also note the wavelength change to 525 nanometers. We'll need to adjust this on the light meter. Carefully place your illuminated compact LED into the LC adapter on the photodetector and wait approximately 20 seconds. 12.9 milliwatts is around the range we expect from the green compact module. Now let's measure the output from the tip of an LC patch cable. Here we are using the LC-LC coupler to attach an LC-LCF patch cable to our green compact measure. Use the tweezers to carefully remove the cover from the LC ferrule tip. Enable the module, double-check your wavelength settings, and then place the tip carefully into the photodetector. "7.7 milliwatts is about what we would expect from the tip of a patch cable connected to a green compact module." Two common issues that can affect your power outputs are debris from the environment, which can occlude connection points and occlude light output, or broken patch cables. Sometimes dirt can build up on the ferrule tip. Remove the dirt with our cleaning solution and wipes, and notice how the output changed from 7.7 to 8.2 milliwatts simply by cleaning the ferrule tip. Here's an example of a broken patch cable. Notice the dramatic reduction in power output. Thank you for your time and attention.